Welcome to The Explainer. Today, we're looking up. We're going to take a really cool visual journey to explore the waning gibbous phase. We'll get into the mechanics, the unique visibility, and even the deep cultural meaning behind the moon's fading light. So let's just dive right in, shall we? Okay, let's kick things off with a pretty foundational question. What exactly happens in our night sky the exact second the full moon phase ends? You know, the full moon gets absolutely all the glory, right? The poetry, the photographs, the whole shebang. But the celestial clockwork of our solar system, it literally doesn't pause to take a breath. The exact instant that 100% peak illumination passes, a new, quieter, but honestly incredibly dynamic phase begins immediately. And that phase is called the waning gibbous. It's the lunar phase right after the full moon. Now, the absolute key word to remember here is wane. In astronomy terms, this simply means the light we see from Earth is actively decreasing. Night by night, hour by hour, the sun's reflected light is literally retreating across the lunar surface. Now, you might hear a word like fading and immediately think dark, but the data tells a totally different story. The illuminated portion drops from a brilliant 99% right after the full moon, gradually scaling down to 51%. So yes, the moon is officially fading, but it's still dominating the night sky with a massive amount of light. It's kind of like a subtle shift at first, one your eyes might not even catch right away if you aren't looking closely. So the crucial point here is how we actually perceive this shift from the ground. Like if you step outside and look up, how do you know for sure you're looking at a waning gibbous? Well, if you're observing from the Northern Hemisphere, it's the left side of the moon that keeps this shrinking glow. The darkness sort of creeps in from the right edge, slowly pushing that visible light over to the left side of the lunar disk. Now, because of where the moon actually is in its orbit relative to Earth and the sun, it follows this really unique nightly viewing schedule. It doesn't just pop up at sunset like a full moon does. Instead, it rises in the evening, well after the sun is already set. Then, it climbs to its highest point in the sky right around midnight, or maybe into the early morning hours. And honestly, here's the most remarkable part. It remains clearly visible right into the broad daylight of the morning. You've probably seen it, right? That ghostly pale moon just hanging there in the blue daytime sky, that's the waning gibbous in action. If you want to track this specific journey yourself, consider this explainer your personal field guide. You've basically got a very specific one-week window to observe this phase. It kicks off the very moment the full moon is over, and it continues its daily fade until it officially hits that 50% illumination mark. In astronomy, we call that 50% mark the third quarter phase. So you basically get this beautiful 7-day countdown to watch the light retreat. Okay, to truly appreciate this whole visual spectacle, we need to introduce a fantastic, honestly kind of sci-fi sounding astronomical term, the terminator. I know, it sounds like a vintage Arnold Schwarzenegger action movie. But in astronomy, the terminator is just the shifting boundary between light and dark on the lunar surface. It's literally the moving border of lunar day and lunar night. And this marching boundary line, it is absolutely critical for observing the moon. When we compare the waxing phases, when the moon is growing brighter, to the waning phases we're talking about today, we see that the terminator moves across entirely different features. The angle of the light is essentially flipped in reverse, which offers us completely new perspectives. This brilliantly illustrates why stargazers absolutely love this phase. Because the terminator is coming in from a totally different angle, it gives us these fresh, completely different views of familiar lunar features. The shadows cast by craters, mountains, and valleys stretch out in the complete opposite direction. So a crater that maybe looked super flat and featureless when the moon was waxing, it might suddenly reveal dramatic textures and deep dark shadows when the waning terminator sweeps across it. The fading light literally reveals hidden details. How cool is that? So far in this explainer, we've spent our time really focused on the hard orbital mechanics and the physical reality of the moon's retreating light. But humanity has been staring up at this exact same sky for millennia, way before we had telescopes or understood the complex geometry of the solar system. So what are the traditional associations here? Like, what does this fading light actually mean in the context of human culture? Well, the physical behavior of the moon has deeply influenced its cultural symbolism. Across entirely different cultural and spiritual contexts throughout history, this specific phase of decreasing light is intimately tied to concepts of release, letting go, and completion. Think about it. The intense building energy of the full moon has peaked, it's passed, and the resulting waning gibbous is traditionally viewed as a period of exhaling. It's this natural, cosmic, visual representation of things winding down and coming to a close. It is genuinely so fascinating how the physical mechanics of our solar system can mirror our own human experiences, isn't it? The moon sheds its light just as we, sometimes need to shed the things that just don't serve us anymore. So the next time you step outside on a crisp morning and look up to see that beautiful, partially illuminated moon just hanging quietly in the daylight sky, think about the astronomical journey it's on and ask yourself, as the light fades, what are you ready to let go of? Thank you so much for joining me for this explainer. Keep your eyes on the skies, and I'll catch you next time.